Hello again. In this section, I will introduce another important data structure to you, that is the queue data structure. In queue data structure, the element follows the first in, first out order, unlike stack where the element actually follows the last in, first out order. In queue, the element that is inserted first will be deleted first. Okay, it's just the same thing that you get outside of a movie ticket counter where people stands in a queue to get a movie ticket, right? The person who is standing first will get the ticket first and will move out of the queue, and the new person who is coming for the ticket will be placed at the rear end of the queue. So the person who is standing last will always get the ticket last. So that's how the queue is actually maintained. It is having two ends. One is the front end where the people gets the ticket, that means the service is provided and the person goes out of the queue, that means the element gets deleted. Another one is the rear end of the queue where the new elements are actually inserted. In this case, the new person is actually placed. So while implementing the queue data structure, we'll consider two ends. One is the rear end where the new elements will be inserted. Another one is the front end from where the elements will be deleted. And in that way, we'll be actually implementing the first in, first out order. So if you can remember the stack data structure where we have only one open end, that is the top of the stack, where the elements are inserted as well the elements gets deleted from the top, right? You cannot insert or delete from anywhere else in a stack. If you are implementing stack, there is only one open end, and that is the top of the stack where we push and pop. But in case of queue, we'll have two open ends. One is the rear, another is the front. In the rear end, we'll be adding the elements. From the front end, we'll be deleting the elements. So we'll have two markers here. One is the front marker, another is the rear marker. Now, I will be implementing the queue data structure using the arrays first, and then when we learn linked list, we'll be implementing the queue using linked list as well. So here is the formal definition for queue. Queue is a linear data structure with two open ends called the rear and the front end. Elements are added at the rear end and deleted from the front end. When we say that a data structure is a linear data structure, that means the elements of the data structure doesn't possess any kind of hierarchical relationship. Going ahead, you'll learn a data structure named tree, where you'll find that the elements of a tree are hierarchically related. There is a parent-child relationship between the elements. But in case of linear data structure, no such parent-child relationship exists. That means each element is an independent element to each other. Okay, now the next point is that elements in a queue typically follows the first in, first out order. That means the element inserted first will always be deleted first from the queue and vice versa. That means the element inserted last will be deleted last from the queue. We typically call it a FIFO data structure. The acronym for first in, first out is FIFO. Now there are some other variations of queue data structure. Firstly, the double-ended queue, where the elements could be added or deleted from both the ends. That means from the rear as well as from the front. You can add a new element at the front end as well as to the rear end. And also you can delete an element from the front as well as from the rear. It's a mixture of first in, first out and last in, first out data structure. I'll be telling you everything about double-ended queue once we successfully implement the first in, first out queue. And then we'll take this double-ended queue. The second one is a priority queue, where the elements gets deleted on the basis of predefined priority. Unlike to the first in, first out queue, where the elements inserted first is deleted first, in a priority queue, the description of the priority actually decides which element is going to be deleted next. Let me give you a good example of priority queue so that you can understand what priority queue is actually. Let us consider a situation. Some students are standing outside of a professor's office for interview of technical assistantship. Now they are standing in a first in, first out queue. That means the student came first is standing first, and the student who came last is at the rear end of the queue. So that's the first in, first out queue. But when the professor comes into the office and starts taking the interview, he declares that no, I don't want the first in, first out order. Rather, the student with the highest grade in the final exam should come first. Okay, so immediately the queue turns into a priority queue. Instead of a first in, first out order, now the student with the highest grade will sit for the interview first. So that's the priority queue. You understand that the grade now is actually the priority condition. The highest grade is now the priority condition. So that's how the priority queue works. A priority queue could be best implemented using a heap data structure. Now, a heap is a binary tree. Now, in order to understand heap, you need to understand binary tree. Now, within the context of this particular course, I'm not going to discuss about the tree data structure. Okay, I'll be creating another course that is going to deal with trees and heaps. So in that course, I'll be talking about the priority queues, how to implement, how to insert elements, how to delete elements from a priority queue. All these things will be there. Okay, enough of theoretical understanding. Now let us move ahead and try to implement the first in first out queue using an array. We'll try to develop the algorithm for insert and delete operation for a queue, for a first in first out queue, and then we'll implement those algorithms using C programming language. Then after that, we will critically evaluate the shortcomings of our insertion and deletion operation, and we'll try to overcome those shortcomings. Let's move ahead. Thank you very much for watching.